let's just move on further towards the combined problems that we all have discussed about all the concepts which involve the properties, the introduction of the rational numbers, and the concept of distributivity, additive identity, and additive inverse. So let's just solve the questions which are all based on all these concepts. So question number 1 says multiply 6 by 13 by the reciprocal of 7 by 16, and the question number 2 says the multiplicative inverse of minus 1 by 8 is what? Why or why not? So let's just start with the question number 1, which says that multiply 6 by 13 by the reciprocal of 7 by 16. So we will start the solution set of this particular question as, first of all, as we know that the number which is given to us is nothing but 6 by 13. We have to multiply 6 by 13 by the reciprocal of 7 by 16. So first of all, we will find out the reciprocal of 7 by 16 as, so let A is nothing but 7 by 16. So reciprocal of A is equal to 1 by A, which means 1 by 7 by 16, which is nothing but 16 by 7. So the reciprocal of 7 by 16 is nothing but 16 by 7. So as per this question, we have to multiply 6 by 13 with the reciprocal of 7 by 16. So according to question ATQ means according to question, we have to multiply 6 by 13 with the reciprocal 16 by 7. So now we will multiply individually the terms in the numerator and the terms in the denominator. So the answer will be 6 into 16 in the numerator and 13 into 7 in the denominator. So 6 into 16 is nothing but 96, and this is nothing but 21, and this is 91. So the answer is 96 by 91. So the answer of my first question is nothing but 96 by 91. Let's just move on further towards the answer of the second one. The second one says that the multiplicative inverse of minus 1 by 8. First of all, it is a mixed fraction. Let's just convert it into the normal fraction. So the mixed fraction which is given to us is nothing but minus of 1 by 8. So let's just solve it. This is nothing but minus 1 into 8 plus of 1 divided by 8, which is minus 8 plus 1 divided by 8. So the answer is nothing but minus of 7 by 8. So hence the multiplicative inverse we have to find out of minus 1 by 8. So the mixed fraction is nothing but minus 7 by 8. We have to find out the multiplicative inverse of this, as we know that the multiplicative inverse of a number A is 1 by A. So let if A is minus 7 by 8, so the multiplicative inverse, of A will be 1 by A. 1 by A means the value of A is minus 7 by 8. So this is minus 7 by 8. So the answer is nothing but minus of 8 by 7. So this is my answer, means the multiplicative inverse of minus 1 by 8 is nothing but minus 8 by 7. This is called as the multiplicative inverse of minus 1 by 8. So why it is called as the multiplicative inverse? Why minus 8 by 7 is called as the multiplicative inverse of minus 7 by 8? Because we know that the answer for the second question, why or why not, why it is called as the multiplicative inverse, this is called as the multiplicative inverse because we know that whenever we will multiply a number A with the reciprocal of that number, the answer is always 1. And whenever a number will satisfy this particular condition, it is always called as the multiplicative inverse. So for the second question, we will write the answer as we know that as as multiplicative inverse is a reciprocal of a number, that is, whenever A get multiplied with its reciprocal, the answer is always 1. So as per this particular condition, we can say that whenever 7 by 8 or minus 7 by 8 will get multiplied with minus of 8 by 7, the answer will be nothing but positive of 1. So these two numbers are actually satisfying the definition of multiplicative inverse. So it means that minus 8 by 7 is nothing but the multiplicative inverse of minus 7 by 8, because they are following this particular condition, and hence the second question is all proved that the multiplicative inverse is first of all minus 8 by 7. So why it is a multiplicative inverse? Because it is following or it is satisfying the condition of the multiplicative inverse, which says that whenever two numbers get multiplied with each other, their multiplication always results in 1. So minus 8 by 7 when get multiplied with minus 7 by 8, the answer is nothing but 1. So this is all about the solution set for these two questions. So let's just move on further towards the question number 3. The question number 3 says find the value of 2 by 5 minus 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. So first of all, before solving this particular question, we have to see whether there is something common in between the fractions and in which fractions there is something common. Then we have to rearrange it using the commutative or either the associative property. So let's just start with it. First of all, we can see that we have the first fraction as 2 by 5 into minus 3 by 7, the second as minus 1 by 14, the third as minus 3 by 7 into 3 by 5. So we can see clearly over here that there is something common in between the first and in between the last fraction. That is nothing but 3 by 7. 3 by 7 is common in the first as well as in the last fraction. So we will rearrange it as, so let's just start with it. First of all, we will say that using the commutative property, or we can also say that we are rearranging it using the commutative property, as we know that A plus B is same as that of B plus of A. We can say over here that 2 by 5 into minus 3 by 7 and minus 3 by 7 into 3 by 5 can be written together with minus 1 by 14 outside. Okay, so let's just solve this particular fraction which is in between the brackets first. So this is nothing but 2 by 5 into minus 3 by 7 minus 3 by 7 into 3 by 5. So the first thing that we can take common out of this particular fraction is nothing but minus 3 by 7, because in both of these fractions minus 3 by 7 is common. So let us suppose I'm taking minus 3 by 7 common from the whole bracket. Okay, we are taking minus 3 by 7 common from the whole bracket, so we get the answer as, so this is nothing but minus 3 by 7 I'm taking common from the bracket. So what is left inside the bracket? Minus 3 by 7 is outside, so over here it is 2 by 5. Again over here, if it is minus 3 by 7 which I have taken outside, so the only thing that is left over here is nothing but 3 by 5 with the positive term, means positive of 3 by 5 is left out. Further outside it is minus of 1 by 14. So let's just solve this particular fraction as minus 3 by 7. Take the LCM inside. 5 and 5 is nothing but 5. So it is 2 plus 3 minus of 1 by 14. Again we will solve it as minus 3 by 7 as it is. 3 plus 2 is 5 by 5 minus 1 by 14. Okay, 5 and 5 get cancelled out with each other and we are left with 1. So this is minus 3 by 7 into 1 minus 1 by 14. Again, minus 3 by 7 into 1 is minus 3 by 7 minus 1 by 14. So what is the LCM of 7 and 14? It is nothing but 14. So this is 7 2s are 14 means minus of 6 minus of 1. So the answer is nothing but minus 7 by 14. So we know that 7 1s are 7, 7 2s are 14. We can cancel the both terms and we get the answer as nothing but minus of half. So it means that the value of all these numbers, that is 2 by 5 into minus 3 by 7 minus 1 by 14 minus of 3 by 7 into of 3 by 5 is nothing but minus of 1 by 2. Using the commutative property, that is a plus b is nothing but is equal to b plus a. So I hope this question is all clear to you, that using which kind of methods I have solved it, and the answer is nothing but minus half. So let's just move on further towards the fourth question. The fourth question says that write the rational number that does not have a reciprocal. What is that rational number which does not have a reciprocal? As we know that there is only such one kind of a rational number that does not have a reciprocal, which is nothing but 0. So the answer of this particular question is 0, because we know that we cannot multiply 0 with any particular number which results with 1. So it means that 0 is the only number which does not have any kind of a reciprocal, because the reciprocal of 0 will be, as we know that if we are writing 0, if I am converting 0 into a rational number, so it can be written as 0 by 1. So the reciprocal of 0 by 1 is nothing but 1 by 0, which is nothing but called as an undefined term. This is nothing but an undefined term. So that is why 0 does not have any kind of a reciprocal. So the answer for the first question is nothing but 0, that the reciprocal of the 0 does not exist, because if it exists, it gives the answer as 1 by 0, which is nothing but called as an undefined term. So let's just move on further toward the second question. The rational number that is equal to its negative, a rational number which is equal to its negative is nothing but again 0. So the answer for the second question is again 0, because 0 is the only number which is equal to its negative, because it's a neutral number. It doesn't talk about any negativity or positivity. So we can say that 0 is the only number which is equal to its negative and which is also equal to its positive. So 0 is the only number which is nothing but equal to its negative. So the answer for the second is nothing but 0 again. So let's just move on further towards the question number 5. Question number 5 says find the sum of the particular fractions, that is 5 by 3 plus 11 by 2 plus minus of 9 by 4 plus minus of 8 by 3 plus of 7 by 2. So let's just start the solution set of this particular question. But first of all, what we have to do before solving this particular question is we have to take out the common fractions, or the fractions that do have something in common with them. So let us suppose I'm talking about the first fraction 5 by 3. I can see clearly that 5 by 3 and minus 8 by 3 has something in common in the denominator, and in the same way the second fraction, that is 11 by 2, and the last fraction, that is 7 by 2, have something in common, that is half. So let us suppose I am using the commutative property again over here. So using the commutative property, let's just start the question. So using the commutative property, we will say that 5 by 3 plus minus 8 by 3 can be written together, and in the same way 11 by 2 and 7 by 2 can be written together. plus minus of 9 by 4 will remain single because there are only 5 fractions available over here. So after solving all these, what we will get, let's just start with it. First of all, in the first fraction we have 1 by 3 in common. So let us suppose, first of all I'll write it as 5 by 3 plus minus is minus of 8 by 3, and further plus of 11 by 2 plus of 7 by 2, plus minus is minus, so this is minus of 9 by 4. So in the first bracket we can say that we'll take the LCM as 3. So in the numerator we have 5 minus of 8, plus in the second bracket we have 2 as an LCM, so 11 plus of 7 minus of 9 by 4. So let's just solve the first fraction within the bracket as 5 minus 8 is nothing but minus 3 by 3, plus of 11 plus 7 is 18 by 2, minus of 9 by 4. So when we will solve the first particular bracket, we get the answer as nothing but minus of 1. So in the second bracket, 2 1s are 2, 2 9s are 18 after cancellation. So it is minus 1 plus of 9, minus of 9 by 4. So let's just solve it. As we know that minus 1 plus of 9 is nothing but plus of 8, minus of 9 by 4. Let's just take an LCM of 8 and minus 9 by 4. Obviously the LCM of 1 and 4 is nothing but 4. So we get the answer as 8 into 4 minus 9 into 1. So this is nothing but 8 4s are 32. So this is 32 minus of 9 divided by 4. So this is nothing but 23 divided by 4. So hence at the end we get the answer of this particular question as nothing but 23 by 4 using the commutative property. I hope all the steps are all clear to you, that using the commutative property I have solved the whole question individually, and after that at the end we get the two fractions at 8 by 1 minus 9 by 4, and after solving it we get the answer as nothing but 23 by 4.